the presentation today is basically what is a Veeam Certified Architect and how do I become certified. And of course, thank you so much for coming in to watch. You may notice there's a little QR code down in the corner. If you're thinking, hey, would love more content on Veeam certifications, intermixed with maybe some VMware content every now and then, that's not a bad place to maybe go and take a quick subscribe. Now, if we haven't met before, great to meet you. My name is Rasmus Haslund. I actually do work directly for Veeam, but I'm sort of more here in a general capacity, I would say, today. I've been at Veeam since 2016, working on the education and certification team. And so I've had the pleasure of doing some presentations and trainings over the years. Would also sort of put myself on the community-loving pedestal, involved in the Veeam User Group here. Also started the Denmark User Group for Veeam, although I passed it on to someone else when I joined Veeam. I always think the user group should be run by the community, not by the vendors themselves. And in case someone wants to connect, of course, hey, would love to, just hit me up on LinkedIn or Twitter or something like that. Unfortunately, I'm not on MySpace, so that's not a good venue for that. Now, I put a little agenda together for today, 5 easy steps that we'll go through. First, we'll take the main topic here. What is this Veeam Certified Architect? Then we'll talk a little bit about some design principles, design methodology. Then we'll go and focus on the exam. And at the end, I would absolutely love to hear from you. Any and all questions that you might have, hit me up and we'll see what we can come up with on answers. If there's something I can't give you right away, that means you've been asking more than fantastic questions, and I'll just take a note on what they are and make sure to come back with an answer, probably in the Veeam Canada user group on the community site, or maybe Chris can send it out. We'll see. So, as mentioned, Veeam Certified Architect. Well, what is this whole thing? Well, it all starts, this journey, with attending a 2-day training. And this is, of course, a instructor-led training. Now, I put on the slide itself a little overview of the course itself. There's a QR code you can scan if you want to easily go to the course description for, of course, a more full description. But basically, in this class, we will go take a scenario and intermix, taking a look at how can we figure out the goals of requirement gathering, infrastructure assessment. So we analyze, we collect all of this information about some fictitious customer, and then we work as a team to go and design a Veeam solution through a long series of exercises. So we constantly learn a little bit, implement it immediately in the exercises, and then we learn a little bit more. We do it again in the exercise. So this design sort of slowly but surely gets populated as we go. Now, one of the things I personally think are very valuable is that we give you this sort of design template almost. It's a Word document that the team is working to use. Of course, it's slightly adjusted so that it works very easily for the scenario that we have in the training. But that being said, you could use that for your own environment if you work for a customer, or if you're a partner, you could go and apply that to the customers that you encounter in the future. Now, as a part of this, we basically gather all of those requirements, constraints, and so on, and we then go and turn this into a logical design. We want to understand feature matching. For example, you say you have this requirement. Okay, well, what do I need from a feature standpoint, but also Veeam component standpoint to be able to actually meet this? And it's mainly about making sure that we've really thought about every single requirement. We didn't let some things slip through the cracks. And let me say, it sounds like, well, I have some list. Of course, I'm not going to forget something. Even in the training, it's very common that at least one requirement will get missed by people. And even when we've identified it and documented it and we start later on, it's still very likely that somewhere in the process it will get lost. That's okay because it's a training situation, but hopefully we won't do the same when we get out in the real world. Now, once we've produced our logical design, and I'll talk a little bit more about that in a bit, but basically this is where we've done a lot of sizing. We know which features, which components, and I don't really know, do I need 10 proxies, do I need 50 repositories, or so and so much, but I do know that I need so and so many terabytes or petabytes of capacity, and across all of my proxies I would need so and so many cores, for example. Then we want to turn this logical design into a physical design, and this is always tricky. So we don't deep dive on this in the training from a perspective of, well, you should go and buy this Cisco CS3260 server, because I don't even know if that's the current model, right? That's the thing. Hardware components are fluid. So we take it a little bit more from the helicopter. What kind of approach should you have? Which order would it make sense to go through from a thought process perspective? And what should we keep in mind as we go through our hardware selection? Then we take a look at implementation and governance, because you're the architect. Are you the one who should be doing the implementation? The question is, of course, not, could you go and do it? Well, maybe you could, right? Just because I'm the architect drawing some nice new bridge doesn't mean that I'm the one to now go out into the field and stand there and pour concrete onto the thing. So we need to have some plan. We need to have a handoff with whoever is actually going to do the implementation. What do we need to give them? How do we make sure that they have the information? If they encounter problems, what is the agreed process from there? And then, of course, finally, they've done some implementation. Things are hopefully working well, but how do we validate our design? We'll give you some different tips. Something just very low level is, of course, is to say, well, maybe there was a defined backup window. Okay, so backups were supposed to finish in 12 hours, maybe. Okay, you sized everything based on the fact that that's going to be the window. Are they actually finishing within the 12 hours? Or are we constantly going over time? Obviously not thinking of the first full, because that's always a bit of a run, but those daily runs, or those recurring runs that we have, are they fitting into the window, the time frame we've agreed? And if they are not, we need to understand, is it an implementation fault? Is it a sizing fault? Did I forget something in the design? Maybe there's some permissions problem somewhere that's preventing the implementation from doing what it should, and it's failing over to something else. Maybe you plan to use direct NFS access and it's failing over to network mode via some 1 gig network instead of the 10 gig NFS network. Just to take some simple example. Now, if you're thinking, hey, where can I go and take this training here? There's a QR code here again. It takes you to the Veeam website for the education center locator. And if it for some reason doesn't show you the correct country, you can always click the little text link and adjust the country, and it'll show you the education centers for whatever location is, of course, convenient for you. Now, if we think about this role, now I'm a Veeam Certified Architect, or I want to be. Well, who is this really for? Well, it's always a little bit tricky, I would say, but anyone who's working with producing designs for Veeam solutions definitely should consider the Certified Architect certification. So you could also think of it like if you find yourself maybe sizing components, or even thinking about what kind of options do I have when I'm doing data protection. Well, then maybe you didn't even think of it this way, but you were probably already involved in producing parts of a design or the entire design. You just maybe didn't have sort of a formalized process that you were going through. Now, in the class here, right, we want to have this 2-day training that's mandatory to be able to go and sit the exam. But it's pretty 50-50 between the lecturing and hands-on exercises. And when I say hands-on exercises, like what does that mean? This is not some traditional lab exercise as you may have tried with other vendors, where you get a remote desktop into some system, you follow some book, says type this, click that, and so on. No, these are all digital paper-based exercises, right? Like I said, we have this Word document, you get a book, or digital or printed, depending on what the education center orders for you, where this scenario is described. And in the training, we've done discovery on your behalf. Discovery can be a little bit time consuming, so we've sort of set it up in a way that you say, well, your colleague has already done this for you, just in the interest of time. And then you get this almost endless list of questions that someone else has been asking. Fortunately, also all of the answers. And you want to analyze this along with the information provided from the customer. Your colleague took meeting notes, so you want to look at those as well. The customer gave you information about the infrastructure. Then we want to start making sense of all of that stuff. But when we want to start passing all of this information, we might all have different ideas about what would be the right way to do it. And so sometimes you might have multiple routes to maybe get to the same end destination, but it could also be that we end up at different destinations. Now, I'm not here to say that, hey, there is only one possible outcome whenever you're working with a customer, because I don't think that that's a fair way to say. That being said, if we've all collected the same requirements, the same constraints, the same information about the scenario, the infrastructure that the customer has, then we should end up with relatively similar designs. So we definitely want consistency. And this is where taking the time to go through the training, but also, of course, studying for the exam starts to pay off. Because it's really critical. I apply this in my daily life, but also at work. I want consistency. And here we definitely want a well-defined process for creating designs. Because what is the alternative? I've seen this happen when I worked as a consultant myself in the past, many times. I open my drawer and I take a look and I see, this customer is probably relatively similar from a infrastructure perspective to this other customer that I'm working on now. And we sort of just almost search to replace some names and tweak it here and there, and then, that's great. That's not really making a design, right? When we go into something like this, we're trying to make a one-size-fits-all. And while maybe that's good for Veeam green spandex suits, it doesn't really fit everyone when it comes to IT. So instead, we want this one clearly defined, but also repeatable process. And that's what we're teaching in the course. Now, the process that we talk about has, should I say, 4 overarching design principles, and of course, a well-defined design methodology. Why don't we try and take a closer look at the design principles first, and then we'll come over and talk about the methodology afterwards. So the design principles, little overview here, right? We basically want to keep it simple. We're looking for simplicity. We want something that's secure by design, flexibility, flexible in iteration, and we want high value. I mean, everyone likes a good value, right? We don't want to pay a lot for something that's not really worth anything. That's just where we feel cheated somehow, right? So if we take a little bit of a closer look at each of these 4 principles, then we can maybe try and define them a little bit better. And the first one, simplicity. If you've worked in IT, I'm becoming an old man here, then you may as also, like I have, even from my early days, heard of the KISS principle, right? We want to keep it simple, and then there's that extra S at the end I'm not going to go into in this presentation. Even if we go far back in time, heck, even Albert Einstein was pushing this principle, right? Keep things simple. Now, it doesn't matter how clever we are. We want to produce a design that's as simple as requirements and the constraints of my customer allows. So you could say, okay, but what is a requirement then? Well, that's of course always a good question. When we think of requirements in our design, they are based on the wants and the needs of the customer. So these needs and wants must be identified by the architect making the design. The issue, of course, is that they are often communicated by my target customer in some non-technical and many times in vague terms. If we try and take a little non-IT related example, I could tell you, you're now designing some product for me. Okay, I could tell you here, a product should not be too heavy, it should be easy to open, it should look high-tech. Okay, fantastic. Now we have some design team looking to convert these wants and needs to some technical design requirements. Okay, so we could say mass of product must be between 0.5 kilo and 0.7 kilos maybe. So then it shouldn't be too heavy. Then the force required to open this product should be less than 5 newtons. Or maybe this surface must reflect at least 80% of incident light to make it look high-tech somehow. Okay. Of course, when things turn into Veeam, it's so easy to start thinking just about the technical requirements, but it's really important that we also think about business requirements, right? It could be something as easy as, well, do we actually have people who can operate this product? Like we don't have availability to go and send people on a training because actually, as it turns out, we have one person. And that's also the guy who goes to fill up the printers with new paper when they run out. So if he's gone for 5 days, we can't print anything after day 1. That's already a problem. Hopefully that's usually not the case, but maybe we can find someone who can come and fill up that printer for that 1 day if that's what really is the issue here. If we think about constraints instead, what are constraints? I think an easy way to think about this. And I see many people get confused about constraints. Typically, we think about constraints as a limitation, something that I can't do. Just keep in mind, it doesn't have to be something that's actively preventing you from doing something. It could be something that potentially is limiting you, but you don't know if it's going to happen yet, right? If I tell you my internet bandwidth is 10 gigabits per second, sound like a lot, but what if it turns out after doing all of the math that I need 20 gigabits per second to make offsite copies? Well, then suddenly it is a constraint. So once we notice certain things that could maybe or maybe not limit us, we could always put them in as a constraint. So another way to think is constraints are conditions that need to happen for the project to be successful. And design constraints help narrow the choices we have available when we create a project. Obviously, I'm trying to put a somewhat positive spin on constraints, but it's just something we have to work with. It doesn't have to be something very negative. We talked about a non-IT example on requirements. We could do something similar here with the constraints. So let's say we're having some dinner party here, some friends. I've assigned budgets. Of course, right? You should always have a budget. When you talk to customers and say they don't have a budget, why are we having this conversation, right? So if you don't have any money to spend, there is nothing for me to work with. Use what you have already. So maybe my budget here is that I don't want to spend more than $40 on all of my groceries. Okay. So maybe we have a friend, Julie, let's say she's a vegetarian and doesn't eat meat, so I need to consider keeping meat off the menu. Maybe Joe has an allergy to peanuts, so it's important that we don't have any nuts or products with nuts come home from the grocery store. Maybe we have Jose, he has some gluten intolerance, so you want to make sure we have some options for Jose as well. And although this event is the start of a fun Friday night, it's probably already filled with constraints that we have to start thinking about. So at first, in the example, any food in the entire world could be on my menu. But then you remember the budget and your choices are already becoming smaller. So like I said, design constraints, they can feel like negative things sometimes, but they are basically here to help shape the project to fit the exact needs of my customer. And of course, in this example here, the result at the end of all of our considerations will be that some meal will suit me and all of my guests. We go to the next one on security or secure by design. Well, security in our design should be considered as far as the requirements allow, or in many cases even demand. But what does that really mean? Well, we could take some examples, right? We, for example, would probably want to minimize our attack surface area. So the principle of minimizing attack surface area restricts functions that devices on the network are allowed to access, typically to reduce potential vulnerabilities. If you think in Veeam terms, you could use some hardened repository. Once it's set up, you disable SSH, right? That's already a minimized attack surface there, as opposed to something that's available on the network. I think most customers, to a certain degree, use a volume at least of default settings. Okay, well, if you think of a job or anything else, oftentimes in Veeam you'll see a button Save as Default. Why not make sure that we have secure defaults, right? So the idea here, the principle is that we want secure by default. And this makes basically sure that we have strong security rules for which servers are allowed to be placed on which networks, how close these firewalls should be. If you have service accounts, well, how often do we need to update passwords? How complex should they be? And so on. And if we then think about that service account, well, of course, we want to operate with the principle of least privilege, right? The service account user here should have the minimum set of privileges required to perform a specific task. There's no reason to create a service account for Veeam in your vCenter and then assign it full administrator rights, unless what you're looking to do is never have to think about anything regarding permissions, of course. Until that day, someone maybe abused it to do something that it shouldn't. Good news is you have tracking of which user it was. The bad news is it could only do those things because you allowed it to go and do it. Why not follow the actually quite good documentation there is and just only give the service account exactly the permissions that it needs? But when we start applying this, you might have, based on all of your analytics, decided, okay, I'm going to, let's say, use a repository. I've narrowed it down based on requirements to 2 options. Which one is more secure? Boom, then that's the one we're going to pick. Or which one is the more simple one? Then that one we'll go with. Oftentimes, simple and secure, that sounds like deviating things, but I would say when we make complex things, that's actually oftentimes where it is not necessarily so secure as it could have been. Or it becomes very difficult to manage, which again is where people oftentimes start cutting corners, which is not really the best, to be frank. If we continue a little bit to flexibility, then what do we have? Well, it's definitely a step-by-step iteration that we're going through here. So we've visioned, we've gathered all of these requirements. Now it's maybe time to actually go and create it. And at Veeam, we definitely favor a iterative method of development here. Meaning we want flexibility so that we avoid these expensive forklift upgrades so that we can instead easily scale out without having to do a complete solution redesign. Instead, we make a design where we have building blocks. Maybe you make a proxy building block, you make a repository building block if you need more storage. Boom, you drop in an extra building block. You need to process your backups faster. Boom, you plop in an extra proxy building block. And we can keep adding these. We don't have design decisions that are locking us down to some state where the solution can't possibly be expanded in the future. Now, as we go forward, right at the beginning, we've defined some scope. Hopefully we've done good discovery. We've understood what we need to cover. But then later on, actually, additional parts of the infrastructure does become part of the scope. Maybe we went out and purchased a competitor, and now we need to merge their infrastructure, IT infrastructure, into ours and also protect it, right? So suddenly you have this blunk, big, huge chunk that you also want to protect. Okay, well, do we now do a big redesign? Well, hopefully not, right? We just need to add more building blocks. That's definitely the plan, at least. Lastly, we had the high value, right? It's one of these cost benefits situations. And if we look at the, should I say, definition maybe of cost benefits, it's basically a analysis of pros and cons of some given situation or course of action to determine the downsides compared to the upsides, right? So basically, we're looking to make sure that, for example, this principle holds the cost so that we end up providing a solution that doesn't exceed the utility or benefit to the customer, right? You don't want to spend $10 million protecting something that's $1 million worth, right? That just doesn't make any sense at all. Now, our architect, of course, is going to sum up potential rewards expected from some situation or action, and then subtract total cost associated with taking that action. Sure, it would be nice to store all of your backups on some speedy NVMe storage, right? I would love to do that. But what justification do we have from our requirements and constraints? And sometimes we have other costs that can be maybe tricky to include. It could be indirect costs, including electricity, maybe overhead costs for management of the solution, some intangible costs like impact on my employees or delivery times or things like that. Because maybe you want something, it takes ages to show up. You have to then renew the contract of the existing solution for 1 extra year. Then you have a cost right there that maybe weren't really part of the budget. So going a different way might end up being cheaper, or even though the equipment was more expensive than you were initially planned, it's still cheaper than paying for that renewal cost, or whatever it is that we're looking at. So these are the sort of overarching design principles, and we want to keep those in mind at every step of the way. If you're ever sitting thinking, well, I have multiple options here, let's take a look at these 4 principles, apply them, make sure that we use those as a guide for making the final decision on what will we suggest and recommend here. The next step becomes the design methodology. And it's a 6-step methodology here. We essentially start off with discovery, right? We want to figure out what you have, what's in the scope, who are the stakeholders. And this is no easy process. And I definitely want to make it clear here that when we talk about discovery and we look at this slide here, you might think, well, okay, I do discovery, I'm done, then I go to conceptual. No. It's extremely rare that you can ever say, I'm done with discovery. Because at the beginning of the project, maybe you only have one single stakeholder. Right? Clearly someone engaged you in this project. Whoever it could be. Then we go and talk to this person. Okay, well, what are the business critical, mission critical applications? What else do you have? We start asking the why question. Who's the owner of that? Oh, so this is someone who's a stakeholder. Got to put that down on the list. Then we have questions for that person. And so the more we ask, typically the more we find out. At some point, hopefully we've gotten almost everything, or ideally everything that we need. But then we want to make sure that we have the right information. So then we maybe narrow the questions down a little bit more to be maybe more specific. And eventually it basically becomes closed questions. I understand that you have ... and you want to do so and so. Is that correct? yes or no. Okay, well then we need to have a conversation to find out where did this go wrong. And don't forget about competing stakeholders who might have different opinions on what do they want to do, and retention, and how things should be done, and so on. Very common situation. Well, then at some point you'll have to figure out whose budget are we spending, and probably that's the person who will be making the final call on some of those decisions, to be frank. But discovery is something that could take a long time, and you'll come back to it. Then we have the conceptual part. This is basically where we try to take all of that big chunk, at least initially, a big chunk of information from discovery. We start making tables, documentation, what are identified requirements, identified constraints. Maybe there's information that we realized we haven't been able to get. Maybe they don't know what their change rate is. Maybe that's an assumption. Just keep in mind, assumptions, you want to eliminate them. Assumptions are basically best effort guesses that we're trying to do here, and we don't want to do a design based on my guess. Maybe I make good guesses and, fantastic, but what about those times when I turned out to be wrong? Right? Surely over time that will happen at least once. So what we then do, of course, is to go back to the customer and say, hey, I need to get this information. Sometimes they'll say, well, we just don't know. We just can't possibly give you this information. We don't know. We have no way of getting it. Okay, well, then you basically have to say, okay, I need this as a variable in the calculations that I'll be doing as a part of your design. Can we agree on an assumption based on my experience that will use a value of 15% or whatever it is? Then we document that. We can't get the information. It becomes an assumption. If we get the information, it's no longer an assumption. It's confirmed data. Assumptions should be unconfirmed data, basically. We move through all of this. Once we've built all of this, it's a good idea to kind of make a high-level diagram. And sometimes people, they get all excited. Oh, yes, now to make something pretty here. There's no reason to deep dive. You don't want to put like 1,000 Veeam stencils. Oh, then we are protecting these VMs over here. There's 1,000 of those, 10 clusters. No, just make a diagram. It's like, okay, we have virtual machines here. That's already more than enough information. We have maybe some physical workloads. Maybe I have something else that needs to be protected, like a database specifically. Maybe it's an Oracle or SQL. If there's like specific named applications that you really want to call out, you can put them there. Next up, we might have multiple locations. Well, you have to get a Veeam backup server. So if you already know where it could make sense to put it, you can put it there. But what about these backups? You probably, based on those requirements, have identified that in that location, we need to have a backup. And then I need to make a copy to that other location. And then people are like, oh, okay, they use public cloud. It's Azure, it's Google Cloud, it's AWS, whatever, service provider, Cloud Connect. So I'm going to write Cloud Connect. No, you didn't make that decision yet, right? Just write cloud and then put the backup there. Right? You don't have to decide that it's going to object storage or cloud repository or something like that. It's just a backup will go to that location. And this is as high level as we need to keep it. That's all perfectly fine. Later, when we get to the next section, if we go to logical, now we'll start to make actual decisions. Will I use object storage? Okay, great. So I've decided that I will use that. Well, now I also know that, for example, I need a scalar backup repository. Just as an example, maybe you have some requirement for immutability. Okay, so then maybe it becomes cloud, maybe it becomes hardened. It depends a little bit here. It could also be you end up with tape, right? So there's so many options, but now we have to start making decisions. Let's say you want to use block storage. The customer has some budget constraint here. They want to spend the minimal amount. Okay, so that means we have to think in how can I avoid storing more data than I have to. It has to match exactly to the requirements. Maybe you want to use ReFS, XFS, something like that. Then we have to write something like down. I need cloning, fast cloning on this repository, just to give you ideas. But now that we've made those decisions in the logical phase, I can continue logical to size every single component. How much bandwidth do I need to send it offsite? Well, I don't know, because I didn't yet calculate how much the backups are going to be. And because I didn't do that, I don't know how big these incrementals are going to be. I need that to size the bandwidth. So it makes sense to have a defined order of what are we going to do here. And in the training, of course, we give you all of that information as well. A little cliffhanger, yeah, but starting off with those backups, probably not a bad place to start. Now, once we've gone through component by component, based on the features and corresponding components that we want to use, then we can go and size those relevant components. At the end, now let's say I've decided I needed 100 proxy cores. Well, now it's time to make a physical design. Here I have to think about things like, well, are we gonna combine certain roles? Like, should I put my repository and the proxy on one box? Well, maybe the answer is easy, because let's say you decided earlier that you were going to use a hardened repository. Well, then we should know the answer is already no, because they can be co-located. So now you have to split them. What if you didn't do that? Well, then maybe you decide to put them on the same. Maybe you decide to split them anyway. But we have to make some decisions here on that. And then, of course, we start looking at things like, well, how much storage did I need in total? Well, how much can I realistically put into one box? Okay, well, then that becomes my building block. How much CPU does each building block get? Memory. And then I already can start to say I need so and so many building blocks for repository, proxy, and so on. And then we get to the implementation governance part. Well, here you have to start thinking, were there certain settings? Because sometimes people get confused about design and implementation. Let's say there was a requirement when you send your backups to public cloud object storage that the traffic had to be encrypted. Okay, well, the traffic is encrypted by default, so no problem. But what if they said the backups there had to be stored encrypted? Ooh, if there was no requirement to store them encrypted on-prem, then obviously I'm not going to do that, because that's extra performance load. You could decide to do it anyway, secure by design, that's fine. But if you decided to do on-prem encryption, then you don't want to put the checkbox to make sure that they get encrypted a second time when you send them out. But if you didn't store them on-prem encrypted, then you have to check that box to make sure that you meet the requirement. But that wasn't a design decision that we're making here. That was a requirement that then leads down to the implementation team. They have to remember to go and put this, and they might forget about it. So we would definitely want that one small detail among many, many potential other pieces of decisions to be a part of that handoff. Who's responsible for what? Yeah, this needs to be very, very clear. Then we have that validation, iteration. Like I said, we've now done the implementation. Are we meeting our backup windows? Are we having errors? Do we have a new scope that's been adjusted? Do we need to do a new iteration? Well, then we go back to discovery. We can run through the whole cycle one more time. So it's a process that seems never ending, but when do you come back for this validation and iteration? You got to give these people a little bit of time. It has to have a chance to run for some time, maybe 3-6 months down the line. Depends a little bit on how long do we need for equipment to show up, all the stuff like that. You might be thinking, all right, this sounds fantastic. Yeah, I would love to sit on this training. Well, I'm happy to hear that you've been excited about that. How did I then become certified? Well, there is an exam, as always. Yeah. Now, before I dive into the details of the exam itself, just in case someone didn't know it, all of the Veeam exams are taken through Pearson VUE, which you may have used to take exams from other vendors. Now, a little bit depending on how those vendors work, you may have been able to go down to your local test center and they just looked you up in the system and they booked it for you immediately. with Veeam, you can't technically take the exam before you've been authorized. Now, to get authorized, it's actually a two-step process. Step one is take the training. We talked about that. Step two, you go to the Veeam website, veeam.com/VMCE. You log in using the email that you used when you signed up for the training. You click Veeam Certifications, the VMCA tab, and then there's going to be under the Schedule Your Exam tab, Manage Your Exam button. And when you click that, this is what the first time, this is when the Veeam system sends that authorization over to Pearson VUE. It's the same for the VMCA exam. Now, maybe that sounds complicated. It's literally like 3 clicks. Now, once that's been done, you can schedule it online, you can call Pearson VUE, you can talk to your local test center, everything is fine. Every now and then I talk to someone and they're kind of confused why they can't do it. They just need to go and press the button. That's usually what it is. Of course, there's different situations. Maybe the education center forgot to report your class for some reason. Okay, that can happen, but thankfully that's a very, very minimal thing here. Okay, so on this exam itself, who is it that can go and sit this? Well, obviously the course, you could go and attend this architecture and design course, but could someone else also do it? Well, in the past we had a course called Veeam Certified Engineer Advanced Design and Optimization. If you took that course in the previous 12 months or so, then it's also possible to go and schedule the new exam. You could potentially do the old one, but it's going to go end of life. So you might want to do the new one instead. Or if you've taken the old course, passed the old exam, you are Veeam Certified Architect version 1, then of course we also let you upgrade. No problem at all. Now, once you sit the exam, what should we expect here? Well, it's nothing overly difficult. You may have heard about old exams where we had endless amounts of math and formulas and stuff to memorize. We don't have that on the new exam. What you'll be presented with, equal to the old one, is 40 different questions. We give you 90 minutes. However, a time extension of 30 minutes is offered if the exam is delivered in a language different than the local language. That's a complicated way to say if you are in a country where the local language is not English, you'll get a 30-minute extension because the exam is only available, as of right now at least, in English. Who knows, maybe it'll be localized in the future. What do you need to pass the exam? You need a score of 70%, ideally better, right? 70% means there was 30% that we missed. Missed opportunity, right? Now, the exam gives you a case study, and there are multiple case studies in the system. So should the unfortunate thing happen that you fail, don't be discouraged about that, but please also don't be surprised that you will get a completely different case study when you take it the next time. So trying to memorize information from the exam is basically useless. Rather, go back, look at the process, try to understand what was it that I somehow misunderstood in identifying all of this information, and then apply that to the new case study. The case study is basically going to be your friend throughout the entire exam. Every single question that you get, the answer you pick as the correct one must be related to that case study. Okay, the questions themselves are typically not very difficult if they were standalone. But because you have to apply them to the case study, you have to understand and process all of that information that they have. Now, on the exam itself, there are different sections. I've listed them out here. We have discovery, 25% of the exam, conceptual design, also 25%, logical design, 25%, and then we have physical tangible, 15%, deployment and evaluation, 10%. So you can see there's a pretty good overlap here with the course. All of the content that you will be tested on will be from this course or the regular configuration and management training. So if you're a Veeam certified engineer, you only need to worry about the new content here. Now, one important thing to know is during the exam, you get the case study, but there are also 5 different tabs. I didn't list them out on the slide, but I'm going to tell you. The first one is an executive overview, basically sort of a summary of what infrastructure, issues, requirements do they have. Second tab, solution concept, a high-level description of Veeam's proposed solution. Tab number 3, existing technical environment before anything Veeam. So basically some specification of what they have. Then we take a look at the existing technical environment. So what does that look like from a technical perspective? We look at business requirements and finally technical requirements that they might have. Now, what is very near and dear to my heart is doing the best I can to help people prepare and ideally pass the exam the first time. Everyone is able to pass this exam, and it's also definitely doable to do it in the first attempt, but some study needs to be invested. And I can say I've already been contacted by more than one person. This exam went live, I think, August 2nd, 2021. And I've already been contacted by more than one person who told me that not until almost the very end of the exam did they realize there were multiple tabs with information. This is pretty clear in the system, but regardless, even if somehow you're stressing, you felt it wasn't clear, it's also described in the exam guide document, right? Important thing is, don't be surprised, know what you're going into. To me, I think they didn't read the exam guide, and that's a big miss because this is the document that tells you what should you expect to be tested on. If you don't know what to be tested on, you're basically going in blind, hoping to wing it, essentially. And that's maybe not the best start point to pass a certification exam. Another good tip I can give you on the exam is that questions do not relate to each other. Let me make a fake example here. This is not something from the real exam. I want to make that absolutely clear up front. So it's maybe not even slightly, maybe very exaggerated, but I just want to make what I'm talking about abundantly clear here. So let's say you have a case study and it tells you that the customer wants 14 days of retention. So you're like, okay, boom, 2 weeks of retention, done. You then are presented with some question that states the customer has changed their mind and the retention requirement is now 7 days. And the actual question then asks you something about how this is affecting sizing. Okay, no problem. You understand, you reply, great. 3 questions later, you're plowing through everything, everything's going great. You get a question and now you're confused because the next question says, how much retention does the customer want? And your answer options are 7 days, 14 days, 21 days, 31 days. Now it's very tempting to answer 7 days because you just learned from the other question that they changed their mind. They changed what's in the case study. 7 days would be the wrong answer because in the exam guide we are very clearly told questions do not relate to each other. You should always go up to the case study to find the correct information. Now, like I said, just to be completely clear, I'm making a very big deal about this in this clear example here. Veeam is not trying to trick you on the exam somehow, right? I just made this over-the-top example to try and get the point across here. Definitely, there's no intention of anything like that. So that's why I said it's a fake example, but I think most people can understand the point here. It's listed as like one line in the exam guide, but I think most people, they don't really know what to expect from that piece of information. Now I'm thinking, what else could I tell you? So, is there something else that you need to know? Yes. Now, you don't have to be experts here. In the guide, it says some technologies are not specifically taught in any of the trainings. They still expect candidates to have some familiarity with them for contextual reasons. For example, Oracle would be on what is RMAN, what is clustering, Microsoft SQL Server, because we don't teach you about these specific technologies in any of the trainings, but we expect you to have an idea that RMAN is Oracle's recovery manager tool that is sort of the official tool to do backups and recovery, and maybe even know that Veeam has a plugin for that. You don't need to know anything about the plugin per se, but like I said, for contextual reasons, if we talk about Oracle RMAN, we don't want someone to sit there thinking, don't know what to tell you, never heard about that before. I didn't realize I was supposed to look up what RMAN means or what is Oracle clustering. So now you know, and you should have known before you went into the exam. I didn't prepare too much more content because I also wanted to make sure that in case some people had questions, that they had a chance to go and ask them. And I also know, put it in the chat, there's a little survey there. So it's definitely very important here that we go and take a look. But if there are some questions, I would absolutely love to hear from you.